Okay, so for the first topic, I'll be going through scalars and vectors. So for this, for videos for this one and further on, we're just gonna assume that you guys know the O-level syllabus. One step up from the O-level syllabus in H2 physics and for SJPO is that you have to learn how to calculate vectors instead of scalars. So you also need to account for the direction. So let's see. I'm gonna be going from easier to harder questions to help you guys better understand. So we have a first force. Okay, let's start our first question. We have a force A that is 5 newtons and a force B that is 3 newtons that is acting along the east and along the north. Since these two forces are perpendicular to each other, we can apply Pythagoras theorem in order to get 5.83 newtons in the end. Then, in order to calculate the angle tangent theta, since we know that the force B is the op and the force A is the adjacent, we can apply the formula DOA in order to get the angle. So that's how we get the resultant force and the angle. So what about two forces that are not perpendicular to each other? Well, what we can do here is to apply the cosine rule. Let's see, we have a force of magnitude 2 newtons in acting east and another force 4 newtons acting 30 degrees east of north. So we know that this is a 90-degree angle and therefore the total force here would be 120 degrees. So using the cosine rule, which is a squared equals to b squared plus c squared minus 2bc cosine A, where A is R, B is 4 newtons, C is 2 newtons, and A is theta. We can just substitute to find the resultant force as 5.39 newtons. And then we can then use the sine rule, since the angle theta and 4 newtons are opposite to each other, this one and this one, and the resultant force and the 120 degrees are opposite to each other, we are then able to get this equation. And since we know R already, we can then substitute to find the angle. So let us now consider the subtraction of vectors. So we have a car that's initially traveling 12 meters per second due east first. So what is the change in velocity? Well, let us draw a diagram for that. So 12 meters due east, and then if it ends up traveling 16 meters due east, since it is in the same direction, we know that there's a 4 meters due east change. So that's how we get 4 newtons to help you visualize. So what about the other question? What happens if it's 9 meters due east instead? Well, in this case, because the speed actually decreased from 12 to 9, the change actually happened in the opposite direction. Instead of east, which is this direction, it will be in the other direction, which is west. So therefore, it is negative 3 meters per second due east, or we can say 3 meters due west for short. And then if it's 10 meters, if it ends up being 10 meters due west and not 10 meters due east, so it would be like this 10 meters and then 12 meters due east. Not like this. We can see that the car completely changed direction, and the change will be in this direction. So therefore it is negative 22 meters per second east or 22 meters per second due west. So how about, let's try and calculate what if there are more than two forces? What if there are three forces? So what we can do is to account for both the vertical forces and the horizontal forces. So to calculate the net vertical force, we can calculate this. We can calculate for each of the individual vertical forces from these three forces. So 500 sine 45, using the formula so for all these equations, we can calculate the vertical force for all of them. However, for this force 300 newtons, since the vertical force is actually acting downwards instead of upwards, we should then be subtracting instead of adding in order to get 723.2 newtons. Then, to calculate the horizontal forces, what we are going to do is we are going to use the formula car in order to, since we know the hypotenuse and we're trying to find the adjacent, we can calculate the horizontal force. And since the 600 newtons force is acting towards the left and we take right as the positive direction, we need to subtract. And then we add the right force due to this force and then the right force due to this one. And then what you will notice is that since the vertical force and the horizontal forces are, the net horizontal and vertical force are perpendicular to each other over here, we can then are able to apply Pythagoras theorem to find the resultant force. And then we use the formula TOA to find the angle after that. So for this question, this is actually quite a common question for SJPO, like a string with a weight. So we have since we can tell that the system is in equilibrium, it means that the vertical forces are equal to each other and there's no net vertical force. So the vertical force upwards is equals to the vertical force downwards. And the only vertical forces applied is from the weight and the tension too. So therefore, by using the formula so to calculate the op, we know that this force, this vertical force applied by T2 is T2 sine 30 degrees, and T2 sine 30 degrees will be equal to the weight. So we just substitute, and then we know that T2 is equals to 2W. And again, since the object is in equilibrium, we can also tell that the horizontal forces, the horizontal force that's acting towards the left is also equals to the right force that's acting towards the right. And to calculate the only horizontal forces applied are from T1 and T2. So we calculate the horizontal force by T2 by doing this, and then we substitute again in order to get square root 3W. So relative velocity. It appears sometimes during SJPO questions. So what you want to do is that if you want to find the velocity of something relative to something, you need to subtract like the velocity of that first thing minus the velocity of the second thing. So you just need to remember this formula. So let's analyze this question. We have a car A that's traveling at a constant speed of 80 kilometers per hour and a truck approaching the car in the opposite direction at a constant speed of 100 kilometers per hour. What is the car's velocity relative to car A? The truck's velocity relative to car A. So using this formula, since we know that the velocity of the truck taking up the upwards direction as positive is a negative 100, and then we subtract by the velocity of A, which is 80, we'll then get negative 180 kilometers per hour, which can also north, which is also 180 kilometers per hour south relative to the car. And then for this question, we have a car traveling due north on a straight road at 90 kilometers per hour. So if we want to use the formula, this same formula, we use this one, the velocity of CL minus the velocity of C minus VL. So in order to do this, we are actually going to make the velocity of the lorry negative and point the other direction to find the sum of the vector in order to get the relative velocity in the end. So we know this angle, since this one is traveling northeast, and we also know the velocity of the car and the velocity of the lorry. So we can then apply cosine rule again in order to get the relative velocity.